Welcome guys. It is I, Joel andile, and today I bring you a lesson of mathematics, grade 12. We are doing sequences today, so please tune in on the video. We'll be doing some cool stuff, some easy stuff, so please guys don't forget to hit that subscribe button, or perhaps your comment, or you like or follow our page guys. Please, your like, your comment or your subscription will be of high appreciation to us. Okay, we begin with the arithmetic sequences guys. So the arithmetic sequences have a general formula, that is Tn is equal to a plus into n minus 1 times d guys. So a will be your first term of your sequence guys. I'll make an example so that everything will be clear. So a is the first term of your sequence. Your n there is the same as that one, so your n represents the position of the term. So if we are talking about term number 1, we substitute there in the place of n, we put 1, so it is the position of the term in the sequence. We come to the d there. The d is the constant difference guys. So the arithmetic sequences have a constant difference. So let's make an example. Maybe you are given a sequence like that: 2, 4, 6, maybe 8, dot dot dot. Let's say maybe up to 108 guys. So this is an example of an arithmetic sequence. You can see that my terms actually differ by 2 there. If I were to subtract 2 from 4, I'd get 2. Subtract 6 from 4 from 6, I'd get 2 also. Subtract 6 from 8, I'd get 2. So this is a property guys, or the characteristic of an arithmetic sequence. It has a constant difference. So anytime you are told that a certain sequence is an arithmetic sequence, this is true. The difference is calculated in this way. You say t2 minus t1, which must be the same as maybe t3 minus t2. So the bigger separates the successive smaller term. So let's make an example. If I were asked to find the equation for that term guys, remember in our equation I'm going to write Tn is equal to, I'm having a there. What is a? I said it's my first term, so my first term is 2 plus, I open bracket, write n minus 1, and I write what is my difference. My difference is actually 2. So if I can put it inside the bracket, it is fine like that, but you can go further to simplify it if you like. For instance, you could multiply the 2 out to have 2n minus 2. Further simplifying, this will be 2n. So you get a mark even if you leave it at this stage, or at least at that stage guys. So this is easy. I'm just going to be putting some questions which we will work through over on these arithmetic sequences. Say for instance we are given let's say 1, 3, 5 up to maybe, let's say I don't know, maybe let's say 86. I'm not sure about that 86. So let's say maybe they pose the first question as find the term or the general rule of that sequence, or simply put, find the equation for that sequence. So first I'd have to get my difference. My difference is t2 minus t1, so which must be the same as t3 minus t2. So my t2 is 3 minus my t1, which is 1, must be the same as 5 minus 3. So 3 minus 1 is 2, 5 minus 3 is 2. So I have that my difference for this arithmetic sequence is 2. My a there, my a is the first term of my sequence, is 1. So if I were to write the equation once more of that sequence, I'd say Tn is equal to a plus into n minus 1 times d. I substitute the value of my a, which is 1, plus I open bracket n minus 1 and write the d there. It's 2. So it's fine if you want to leave it at that point, but you can go further to simplify it by opening that bracket 2n minus 2. So my equation is 2n minus 1, the simplified version of it. Okay, let's say maybe they also pose another question. They tell you that a certain term, guys, of this sequence is, let's say maybe is 55, They tell you that a certain term, or rather, let me first, let's say maybe it's 49, guys. Let's say it's 49. They tell you that a certain term of that sequence is 49, and they ask you to determine the position of that term, guys. What term is it? You don't know which term of the sequence is that, so they ask you to determine the n. So I'm just going to write my equation. Tn is equal to 1 plus, or rather, let me write the simplified version, 2n minus 1. So what they've given me here is the Tn, and they are asking me the n, guys. So my Tn is 49 is equal to 2n minus 1. Then if I were to solve for my n, I transpose the 1 there. In order for it to be 50 is equal to 2n dividing by 2, I get that my n is 25. So it means, guys, my T25 is actually equal to 49. So they will say which term of the sequence is equal to 49. So this is how you approach that question. Moving to the next question, they may ask you, say for instance you are given that number, I'm not sure, let me say it's 85, let's say 85 there. You are given, guys, that your sequence starts from 1, 3, 5, and then it continues and stops at 85. So your 85 there is the last term of your sequence. They ask you how many terms does this sequence have? How many terms does this sequence have? So I told you that this is the first term, the second, the third. We don't know what is the position of that term. So if they ask you how many terms does the sequence have, what you have to do is also solve for n. So I'm just going to write my equation once more, 2n minus 1. So you know the last term that it is 85. You want to know its position. If you know the position of the last term, it means you know how many terms the sequence have. So for instance, if you find out that the position of that term, which is 85, is in position number maybe 50, we could conclude that this sequence has 50 terms. So this is what we are actually going to do, guys. So 2n minus 1, solving my n once more, I transpose my 1 in order to have 86 is equal to 2n divided by 2. I get my n is equal to 43. So I have that this term, which is 85, so it is in position number 43, which is equal to 85. So if the last position is in position number 23, it means that I have 23 terms. So your last mark, in fact your final step should be that one. So you'll be given a mark in substituting that 85 there and equating it. and solving for n. So this question may be a 2 or 3 mark depending on the capacity of the paper you'll be writing. So moving further, guys, I want to make one more last example on the arithmetic sequences so that we can move. There's nothing much about it. So you may be given maybe terms, I'm not sure if it will be visible there. You may be given terms like 2x minus 1, maybe x minus 1 and x plus 3. And I say dot 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 dot. Yeah, I think it's visible. And they tell you that that sequence is the arithmetic sequence. That is an arithmetic sequence. They ask you to find the value of x, or rather they will ask you to find the 25th term of the sequence. In that case, guys, if you are asked maybe to tell what is the value of the 25th term, they are telling you to find T25. What is the value of the 25th term of the sequence? So you'll have to go to the equation in the place of n and substitute 25. So T25 will be equal to 2 into 25 minus 1, and you find what T25 is. So coming here, you are told that that is an arithmetic sequence, and you are asked to find the equation, or rather solve for x. So what you need to do, because you are told that this is an arithmetic sequence, you know that the arithmetic sequence has a constant difference, which is calculated by T2 minus T1, which is equal to T3 minus T2. So you have to take your T2 there. You are taking this part now. We are taking this part and dealing with it. I'm going to take my second term there, which is x minus 1. And I say minus, I put my T1 there. Guys, this is the very most important step. When you substitute here, you need to open the brackets. So I'm going to open my brackets and write my term number 1, which is 2x minus 1. This should be equal to, when I substitute my term number 3, which is x plus 3, I say minus now, x plus 3 minus. Remember, I also open brackets, guys. Please don't forget to open the brackets, because many times you'll go wrong because of the brackets. X minus 1. I'm hoping it is visible there. So I further simplify this. I write my x minus 1 and I say negative times minus my positive 2, I get minus 2x. Minus times negative 1, it's positive 1, which is equal to x plus 3 minus times x minus times negative 1 plus 1. And I solve for x, guys. I will continue with this. So x minus 2x will be minus x. So I'm having x minus 2x will be minus x. Minus 1 plus 1, they will cancel out. So I'm left with minus x on this side. So x minus x is actually not. So 3 plus 1 is 4. So I'm having it that my minus x is equal to 4. So in order to completely solve this, I divide by negative 1 so that my x is equal to 4. Now if they ask me to find the equation now, firstly they ask you to solve for x. So you are always going to use the fact that the arithmetic sequence has a common difference. If they now tell me to find what my equation is, in order for me to find my equation, I need to go back to those terms and substitute the value of x in order for me to have my first term as a number. For instance, we'll substitute in the place of x there minus 4. So I'm going to say 2 times minus 4, which is minus 8, minus 1, minus 9. I go in the second term and substitute x, which is minus 4. Minus 4 minus 1 is minus 5. I put a comma, I go to my third term, I substitute my minus 4 plus 3. It's actually minus 1. So I'm having my first three terms now as values, guys. This is very important. If you can solve for x, please do substitute if you are asked maybe to find the 25th term of the sequence. So from there I can make my equation and calculate my difference. My difference, I would say minus 5 minus 9. I'm thinking I will get positive 4. And I say minus 1 minus into minus 5, which will also be positive 4. So I'm having it now that my difference is equal to positive 4. My A is equal to minus 9. Now I can write the equation. Tn is equal to, in the place of A, I put minus 9 plus into n minus 1 times positive 4. So that's it, guys. That's how we find the equation. So if you can find the equation, at times you'll be asked to calculate what the 25th term of the sequence, or maybe they will give you a sequence like this and tell you to calculate the 25th term of the sequence. So you have to go through these steps. If there is something you missed, you can pause the video and go back. So I want us now to move to the next sequence. Moving to the quadratic sequence now. So the quadratic sequence has a general formula of that form. Tn is equal to an squared plus bn plus c. So the properties of a quadratic sequence is that they have a second common difference, guys. So in arithmetic sequences, we had the first common difference. So we are saying now in quadratic, we are having the second common difference. Now I need to get a sequence here because I cannot create my own quadratic problems, guys. I want to get a sequence here so we can get going. Quadratic. Wow. I've got one. So it is 321, 290, 261, 234. So guys, this is it. The first and foremost important part is that you cannot conclude that this sequence is a quadratic sequence unless you are having 4 terms. So you are going to at least need 4 terms in order to conclude that this is a quadratic sequence. So firstly, we get the difference in order to prove the point that the quadratic sequence has a second common difference. So we say 290 minus 321. I'm guessing that is minus 31. We say 261 minus 290. I'm not having a calculator here, guys. I'm guessing this is minus 29. We say 234 minus 261. This must be negative 20. It's 26. It's 234. it's 27. It's minus 27. So I'm hoping that I'm having this correct, guys. So that is our first difference there. We go further to find another difference, guys. This is the difference we say must be common. This is the second common difference. So we say minus 29 minus into minus 31. So this must be positive, guys. 2, we'll be having positive 2 there. We also say minus 27 minus into minus 29. This is also positive 2. So you can see that if you were to continue with this sequence, if maybe you had other terms, you'd find out this difference is actually common, will be 2 all the way to the right hand side. So there will be a way in order to find the equation of that form of a quadratic equation. So our common difference, guys, we equate it to 2a in order to find our a. So you need to memorize it. Our second common difference is actually equal to 2a. So if actually you were to divide by 2 there, both sides, you'd find that your a is equal to 1. The first term of the second difference, guys, is equal to 3a plus b. So I'm saying the first term of my first difference is equal to 3a plus b. You need to memorize that 3a plus b. So since we've calculated a as 1, I'm going to substitute in the place of a1 plus b is equal to minus 3. Then I solve my b. If I could calculate clearly here, I think my b would be minus 6. So please also memorize this. The first term of the sequence is equal to a plus b plus c. So a plus b plus c is equal to the first term of the sequence, of the quadratic sequence. So I'm going to rewrite that equation. A plus b plus c is equal to the first term. What is our first term? It is 321. I've calculated my a to be 1, my b to be minus 6. Now what could be my c? If I could solve this correctly, I'd get that my c is equal to 326. So finally, writing the equation in that form, Tn is equal to, in the place of a, I will write 1 and then write n squared. In the place of b, I'm going to write minus 6 and substitute n. In the place of c, I'll write 326. So that is how to find the equation, guys, of any quadratic sequence. So if you missed some of the steps, you can pause and go back. I'm just going to be moving forward. So in that equation, guys, that says Tn is equal to an squared plus bn plus c. Our n there, our n is the same as the one on the arithmetic sequence formula. The n there represents the position of the term. Now if they say calculate the term, the 25th term of the sequence, they will say determine what is T25. They are saying you should take your equation and substitute in the place of n. So my equation is Tn is equal to n squared minus 6n plus 326. They asked me what is T25. So I go there and write T25 in the place of n. Since I've written 25 here, it means I'm going to write 25 all the way till the end in the place of n. 25 squared minus 6 into 25 plus 326. I don't think I'm going to be able to predict that answer. So I'm going to leave it like that. So you can see that after you've written this, you will punch on your calculator and get what the value of T25 is. So your marks here you'll be awarded a mark of substituting 25 in the place of n. You'll be also rewarded a mark for writing the final value there, which I cannot write right now. I cannot write it. So another thing they could ask you is that which term of the sequence is equal to maybe 826. 826. They ask you which term. So they are giving you that Tn is equal to 826, guys. So what you have to do is to take your equation in the place of Tn, substitute 826 is equal to n squared minus 6n plus 326, and solve for n there, guys. Remember, this is a quadratic equation. We dealt with how to solve for quadratic equations. You use that quadratic formula actually, which is x is equal to minus b, x is equal to minus b plus or minus root of delta divided by 2a. So you'd have to first here transpose your 826 to that side, and you'd get 0 on that side is equal to n squared minus 6n. So 326 minus 826, that must be minus 500. So from this gap, you'd substitute there, guys, in that equation. In fact, it is not x here, it is n, because you are having n as a variable there. So guys, I want to rather tell you this. You know that always when you solve a quadratic equation, you will get two values. You will get two values of n there. So any value which is not a whole number, guys, do not even consider it. Or at least when you get your two values of n, go back on the original equation. If you say maybe n is equal to 36 or n is equal to 37, if you are not sure which answer is correct, go to that to the original equation and substitute n. Whichever gives you the number you are given, 826, is the correct value. If you are having a negative number, say you are having n is equal to minus 36 or n is equal to 37, do not even bother yourself. The position of a number can never be negative. So if you are having a negative number, it can never be correct. Also, the position of a number can never be in a decimal. So if you are having the number maybe positive 37 and 36,66, do not even consider. Take the whole number. The position of the term can never be a decimal. So this is all about, guys, the quadratic sequence. There's nothing much there. One thing that I forgot, it's a pity I've already wiped the board here. If I can just get the values back, 321, 290, 261, 234. So we said our difference there was it was minus what, 81, yes, minus 31, minus 29, minus 27, then 2. Guys, there's a question that will come. Before we deal with that question, I want to make you see something here. We said this is a quadratic sequence. That is true, guys. This is a quadratic sequence because it has two differences and the second one is actually common. If you were to look, guys, at the sequences of the first difference of the quadratic sequence, you could see that they form what we know as an arithmetic sequence. So if you consider minus 31, minus 29, minus 27 as a sequence, you could see that we are having the difference between them, which is 2, and the difference, which is also 2. So we are saying the first difference of the quadratic sequence forms an arithmetic sequence. So they could ask you this way, guys. They say which term of the first difference is equal to 20, let me say maybe minus, let's say minus 15. They ask you which term of the first difference is equal to minus 15. If they say which term of the sequence, guys, I've already told you how to deal with that. You'd be having your equation of Tn is equal to a plus, in fact, let me substitute my a is minus 31 plus into n minus 1 times my d, which is actually 2. And they asked me what is the value of minus 15. I know that they've given me the value of Tn. Minus 15 is equal to all that, then you solve for n. At times, they'll ask you which term, what is, let me see how this, maybe they can say which term of the first differences must be equal to a certain term there. If they say which term of the first differences is equal to the term there, let's say that term is maybe 210, let's say 86. Which term of the arithmetic sequence is equal to 286 in the quadratic sequence? So what you have to do is take the equation of that and equate it to that 286. And you solve for n, you will get the term which you are asked for. So moving quickly, guys, I want us to move now to the geometric sequences. The geometric sequences, guys, have a general equation of AR to the n minus 1, where your A still is the first term of your sequence. R also by a common ratio. So in ratio, so we term number 2 divided by term number 1. F milling and term number 3 divided by term number 2. So your n there still is represent a position near term on the sequence. So quickly making an example, you could be having 1, 2, 4, 8, and let's say dot up to, let's say 64. So if, guys, I were asked to find the equation of that geometric sequence, remember they will tell me that this is a geometric sequence. So we are saying for a geometric sequence, when we are dividing the second term with the first term, it should be the same when we are dividing the third term with the second term. This is a common ratio. It is a ratio. So if I were to calculate what T2 over T1, which is 1, must be the same as my T3 over my T2. So 2 divided by 1 is actually 2, guys, and 4 divided by 2 is actually 2. So that is what we are saying in the geometric sequence. We are saying we are having a common ratio, guys. So if I were to completely write the equation of that geometric sequence, I'd say Tn is equal to, in the place of A, I write my first term. What is my first term? It's 1, so I write 1. I open brackets, I write my r. What is my r? It's 2, then raise all that to the n minus 1. So that is how to find the equation of any geometric sequence. Now if they ask me which term of the sequence, or they say maybe find the value of the 86th term, they ask me to find what T86 is. So what you do is go there, in the place of n you write 86 as I've done there, and do the same for that one. 86 minus 1, then punch your calculator. Then hour do a mark for substituting in the place of n 86, and hour do a mark for writing the value of 285, and you punch your calculator, guys. These are easy questions. Also, if they ask me what is the position, which term on the sequence is equal to let's say which term of the sequence is equal to 60, let me say maybe 27. They ask me which term of the sequence is equal to 27. So there also they are giving me Tn, guys. So I go in the place of Tn, substitute 27, then I solve my n there. You could say that you can solve your n, or rather let me say 32 there. Which term of the sequence is equal to 32? And I substitute 32. I solve for n. How do I solve for n? I use the laws of my exponents. I can raise 2 to the power 5, which is the same as 32, 2 to the n minus 1. When you are having same bases, you can equate the exponents, then having your n as equal to 6. That is how easy it is, guys. Now let's come to when they question it tricky. You may be given that maybe a certain sequence has let's say 1x, maybe should we say y? Or let's say 2, or let's say they give me only those 3 terms, guys. They tell me that it is actually a geometric sequence. So if they tell me that is a geometric sequence, and they asked me to find the value of my x, how are you supposed to deal with that? Also, you will use the fact that the arithmetic or the geometric sequence is equal to, or let me, so has a constant ratio, which is T2 over T1, T3 over T2. So in the place of my T2, remember I will use this part only. In the place of my T2, I write x divided by my T1, which is actually 1. And I also say is equal to my T3 is 2 over my T2 is x. Then I solve for x, guys. How do you solve for x? Cross multiplication. I say x times x, x squared is equal to 2 times 1, 2. Then I root both sides in order to have x as being plus or minus root of 2. That is how to find the value of x, guys. So I hope you see how to deal with these things. So I'm just going to try to look at questions that are questioned here. Tomorrow we'll be moving, or rather on our next video, we'll be moving to series, guys. We'll be moving to geometric and arithmetic series. So I think we've done much for today. Oh, there's one I keep forgetting. Okay, maybe we'll deal with it in another lesson. So this is it, guys. Please rewatch the video and don't forget to share the link of the video to those who may need it. Remember, your subscription to our page will be very much appreciated on our channel. Please, goodbye, guys. Take care.